So what happens if oxygen is present? We saw what happens when oxygen is not present. We go from glycolysis to fermentation to regenerate our electron carriers, our oxidized forms of our electron carriers. But if oxygen is present, then our products are going to move into the mitochondria. And this is where the site of oxidative phosphorylation and the Krebs cycle are going to take place. So glycolysis has occurred. We have our pyruvate. We have our 2 ATPs from glycolysis and our 2 NADHs. So from here, pyruvate is going to enter the mitochondria by active transport. It's going to enter into the matrix, where it's going to be converted into acetyl-CoA and then go into the Krebs cycle, where we're going to make more reduced electron carriers that will then enter the electron transport chain and make the bulk of the ATP through chemiosmosis. So the first step of our pyruvate oxidation is we're going to first remove a carboxyl group in the form of CO2, and that CO2 is going to be released. Then we're going to do a redox reaction. We're going to pull electrons off of our leftover pyruvate molecule. We're going to give it to NAD+ and reduce it to NADH. And we're going to tag on a coenzyme to this to form acetyl for the 2 carbons that are left, CoA for the coenzyme to help out with the first step of the Krebs cycle. Now keep in mind, these carbon dioxides that we're going to see come off are the carbon dioxide molecules that you are breathing out right now. The oxygen that we are going to talk about is the oxygen molecules that you are breathing in. So as you're doing this, your cells are doing this process as we speak, and you're not even thinking about it. So once we get acetyl-CoA, it's going to bind to oxaloacetate, which will form citrate. So oxaloacetate is a 4-carbon molecule, and we're adding a 2-carbon molecule to it, and we get a 6-carbon molecule. And we're going to remove 2 carbon dioxides, and we are going to reduce NAD+ into NADH, and we're also going to reduce FAD into FADH2. For each pyruvate that is converted to acetyl-CoA, we get 2 carbon dioxides removed, 3 NADs are reduced, and 1 FAD is reduced. And then we're going to form ATP by substrate level phosphorylation. That is what SLP means, substrate level phosphorylation, but it's an indirect process. We first form GTP, which is another nucleotide triphosphate, which will then be converted into ATP. We want to multiply these values times 2 to get a total for glucose, because remember, we broke glucose in half into 2 3-carbon molecules, so we need to look at the totals for 2 acetyl-CoAs. Once again, you do not need to know the specific intermediates or their enzymes, just what goes in, what comes out. The rest of the cycle, after we pull off these 2 CO2s, the rest of the cycle is used to regenerate our starting molecule, oxaloacetate, so we can bind acetyl-CoA to that again, and the whole cycle can continue again. And it just keeps going